Hello everyone, thank you all for joining our webinar. Good morning, good evening, wherever you are. My name is Felix Schuster. I'm the co-founder and CEO of Edgeless Systems. We are a company based in Germany, building tools for confidential computing, and we are backed by renowned investors like the Swiss Stock Exchange. And one of our focus areas are financial services. And today, with me on the stage, I have these two fine gentlemen, Giuseppe and Andung from Accenture Labs. Great to have you, and yeah, please feel free to introduce yourselves.
Thank you, Felix, and I'm very pleased to be here. Hello, everyone. I'm Giuseppe Giordano. I am one of the senior managers at the Accenture Labs in Sophia Antipolis, south of France, and I lead the team that specializes on multi-party systems, privacy-preserving computation, and confidential computing.
Thanks, Felix. Likewise, I'm pleased to be here with you. And my name is Andung. I'm R&D specialist in the labs, Accenture Labs here, based in Sophia Antipolis. And yeah, I've been participating in various activity and projects here. And now my main focus is on confidential computing.
Excellent. Great to have you here. Yeah, so the structure of today's event is as follows. We have roughly 4 segments. So the first one is I'll give a very brief intro to confidential computing to set the scene. And then Giuseppe is going to take over, and Giuseppe is going to discuss several exciting use cases for confidential computing in the financial industry. And Andung is going to follow that with a very cool demo of a confidential insurance claims fraud detection app that they built with tools that we built at Edgeless Systems. So this is how everything ties together. We at Edgeless Systems, we're building tools. Accenture is exploring and addressing very interesting use cases and using these tools in the process. And the 4th segment, I'm going to talk about how we as a company are providing next level protection against data breaches using our confidential computing products. And we close with a round of Q&A. That's the rough agenda. And now I'm going to give you, as promised, the brief introduction to confidential computing. And give me 1 second to find the right screen here. Add to stream. There we are. Full screen. All right. So let's start with the problem that confidential computing is addressing. How to securely process data on someone else's computer. That's a very complicated and interesting problem, and it has specific relevance when we think about the cloud, because as all of you probably know, the cloud is just someone else's computer. And if you're running your workload on the cloud, you have to give all your code and data to the cloud, and you have essentially hope for the best. And that is acceptable in certain circumstances, but not acceptable in other circumstances. And confidential computing can solve this. And confidential computing is a hardware-based technology that allows you to isolate your workloads on someone else's computer and to keep them encrypted even during processing. And finally, also to verify that this is the case, like that there is indeed an isolated and encrypted environment that's running precisely your code. And then you can bootstrap a secure channel to that secure environment, send over your data, and process it with confidence while knowing that no insider or hacker in the cloud infrastructure can access your data. That's the idea of confidential computing. And it's a pretty amazing thing, and it solves a great problem. How does it work? So from a technical perspective, it's all based on hardware. So if we take a look at the current software hardware stack that we see in the cloud or essentially anywhere these days, it's looks somewhat like this stack here. On the top layer, we have our application, then we have a guest operating system, then we have a host operating system, a hypervisor, and some hardware. And in all of these layers, different attackers can hide and can use different vectors to attack our workloads. Now, the idea of confidential computing is to have the CPU create something that is called a secure enclave. And the CPU will make sure that the secure enclave is isolated, runtime encrypted, and verifiable, as discussed before. And inside the secure enclave, you can essentially run arbitrary code and data. And this concept was pioneered by Intel with the SGX technology around 2015. Back then, I was still working at Microsoft, was probably one of the first to work with the tech at Microsoft. And yeah, since then, it has spread essentially across all of IT, all of cloud computing, and it's now an emerging trend and a hot topic. And the concept of SGX has, in recent years, been extended to not only apply to specific apps, but to apply to entire virtual machines. And this is now called confidential VMs or confidential virtual machines. It's essentially the same thing as a secure enclave, but it has higher compatibility. And the technologies that are related with confidential VMs are AMD's SEV, Intel's upcoming TDX, and ARM also has a technology called Realms that was introduced with the recent ARM server CPU architecture. So the confidential computing hardware is surprisingly prevalent. So most of the clouds have it these days. So you can get confidential VMs, secure enclaves on Azure. You can get it on Google Cloud. You can get it on Oracle. To some extent also on AWS and other clouds. So it's really no problem at all to get the right foundations. What is more difficult is to get the right software and to really tie everything together such that you really get an end-to-end secure, always encrypted and verifiable environment around your application. We believe that confidential computing will eventually be everywhere, and we're not the only ones. So here's a quote from Mark Rosinovich, the Azure CTO, a quote that he made at our conference, the Open Confidential Computing Conference earlier this year. And he was essentially saying, okay, the future of the cloud and the future of computing in general is confidential, and we are heading towards a fully confidential cloud. And I think this is a very bold statement and a clear sign how important confidential computing will be going forward. So finally, before I hand over to Giuseppe, the use cases for confidential computing. So there are plenty, and the two main classes, from my perspective, are first, enabling multi-party data sharing. And Giuseppe is going to explain what that means and what that means specifically in finance. And the second big use case is pretty simple, preventing data breaches. And I'll be talking more about that in a bit. And with that, I'd like to hand over to Giuseppe. Let me get you back on stage. Ah, there you are.
Thank you, Felix. And let me share my screen. Okay, so my slides should be up. So before I get into the topic, really a few words about the Accenture Labs. Just one slide very quickly. So as I said at the beginning, the lab is the R&D organization within Accenture, 200 researchers worldwide, over 700,000 people company. So pretty small group, but very, very impactful, because we are really the guys at Accenture who work on the next wave of technologies that will impact Accenture, our clients, and our partners. And I lead the team in Sofia Antipolis, among all the other labs. And really, the focus of my team for the last 5 or 6 years has really been around multi-party systems, confidential computing, and privacy-preserving computation. Getting into the topic now, before I really deep dive on confidential computing, I wanted to introduce this concept of data cooperatives, which for us is really the overarching theme that includes all the work that we do around confidential computing and privacy-preserving technologies in general, so not only hardware-based. And normally the way we introduce the topic is to use this Lego analogy. And if you look at the left of this slide, basically the message is that if you look at three companies or three entities within the same organizations, A, B, and C, that do not share data, do not collaborate, all they can do is to build something which is more or less sophisticated, depending on the type of data that they have, depending on the quality of the data that they have, depending on the skills and the people. On the other side, what we say is that if you enable the construct of a data cooperative, which is also privacy preserving, the three companies can really virtualize and build a single unique virtual data set, which comes from the aggregation of the three individual data sets, and build something which is way more sophisticated than what they could build individually, hence the castle on the right. And what is the magic? The magic is really in the way we built that safe locker in between, that is privacy preserving, and the way to build that is to really use tools that include confidential computing and privacy preserving technologies. So that's basically our overarching theme around data cooperatives, which is really a construct that allows to collaborate while keeping the assets, so both data and models and algorithms encrypted without having to decrypt before you use them or while you use them. That also means that it's a new way to expand access to data sets that you could not consider in the past because of IP, competitivity, and market relevance. And then, of course, more data, more powerful model, new and valuable insights that you can build out of the data and the collaboration with your peers, partners, as well as competitors. So technically speaking, the way we look at this is these days is really about not making a religion of a single technology, of a single vendor, but really try to build a modular framework that supports both confidential computing and privacy-preserving techniques, really as a plugin. And the idea is that depending on the use case, depending on the requirements, depending on the industry, depending on the regulatory landscape, that of course is very, very important these days, the idea is to select and combine the different techniques and modules in order to deliver this type of use case. And of course, these days, we really have to be cloud ready, as Felix said, but at the same time, infrastructure agnostic, because we also know that sometimes we deal with cloud, but sometimes we also have to be ready to work with deployments that require some on-prem technology. So in terms of the modular approach, we look at this is really about basically using existing data analytic assets that could be the ones that we have at Accenture as a proprietary software, but also cloud native tools, for example, on Azure, on AWS, and really underpin those existing data analytics and machine learning assets with this privacy preserving toolkit, where we have different plugins for data de-identification, different plugins for secure enclaves, trusted execution environments, homomorphic encryption, collaborative learning that includes federated learning as well as split learning, and multi-party computation. And really for us at Accenture, our role is to try and abstract in the best way possible all the complexity of those very specific and very low-level technology tools, and give in the hands of the engineers, data scientists, business owners, a tool that they can use to really work on data while collaborating with people in a privacy-preserving way, with other organizations in a privacy-preserving way. In terms of use cases, Felix mentioned two main use cases. We have 5 categories that very much fit into the two families that Felix just mentioned. And really, based on our experience across the globe and across different industries, we've seen many use cases and also different options in the way you can use and combine different PPC and confidential computing tools. For sure, there is a very much traction these days around moving sensitive data and workloads in the cloud, and this is definitely where confidential computing has a sweet spot. This is not about multi-party use cases. This is not about data collaboration and sharing. This is about a single organization that wants to move the data to the cloud while protecting from the cloud infrastructure providers. Then we've seen use cases like the data marketplaces and data monetizations. These are the companies who want to monetize their data and their models or their algorithms and make that available to others while monetizing them without giving them away. So protecting the confidentiality as well as the IP of those models, for example. Then we've seen a number of use cases where it's about executing private algorithms over third-party data. This is very much into the IP protection of the algorithms. I want others to use my algorithm on their data or the other way around, using these kind of techniques in order to protect the IP and the confidentiality of both. And then in terms of multi-party, there are mainly two types of use cases. The first one is the privacy-preserving collaborative data analytics. So you aggregate virtual data sets with contributions coming from the different actors, and then you start running data analytics, secure query. You run your statistics over the aggregation of those data sets, of course, in a privacy-preserving way. And then, especially with multi-party computation, where definitely confidential computing has a role to play in order to make that more scalable and secure. We've seen all the use cases around artificial intelligence and machine learning, where, for example, you train a model in a collaborative fashion in order to build something which is way more robust than what you could build individually because you have much more data available. This is the perfect use case where, for example, you start combining federated learning with confidential computing, for example, for the secure model aggregation. Now, in terms of financial services use cases, I just have a few examples, and then my colleague Andung will take over and show you an insurance claims fraud demo. But two use cases that we've recently seen and that we've been discussing and trying to imagine on confidential computing are basically these ones. The first one is about consumer credit risk modeling. And you all know, especially for the people in financial services, how important it is today to have strong models for credit risk before you issue loans, basically, to people. And normally this is now done in a centralized way where all these different companies provide the bureaus with different data sets, and the bureaus have some specific models that they train, and depending on the different inputs, they release a certain credit risk associated to each of the potential customers. The idea and the future could be about imagining the evolution of all this, leveraging confidential computing so that all the banks, card issuers, financial institutions could bring their data in a secure enclave, in a confidential computing environment, where the bureau could run as a service the model, or simply outsource that, or being completely disintermediated in a way that the model basically learns from the data in a secure environment, which is confidential computing protected, and then basically the credit risk score comes from the secure enclave in a privacy-preserving way so that none of the participants can access the data from the others, but still leverage a model which is way more powerful. Another use case that we've seen, especially very relevant these days, is about data sharing to evaluate financial risk exposure. And imagine basically what happens today. The banks don't really share much transparently information about their financial leverage, asset liquidity, counterparty risk exposure, and so on. And this can lead to basically very risky situations that can be systemic for the full system, right? So the idea, and one idea of using confidential computing would be for all those banks to aggregate basically their data, bring them all together in a confidential computing environment, and then from there, basically evaluate the systemic risk, for example, at national level of the full system without having the regulator nor each of the banks access the data coming from all the participants in the system. Of course, very sensitive data, very confidential data, to be carefully managed by encryption and to be carefully managed and attested once they are in the enclave, basically to run this system that can help the country to manage the risk exposure at the systemic level. And then for the demo today, the use case that we wanted to present, which of course is a simplified version of the real one, it's basically an insurance use case where we use confidential computing to build what we call a data clean room, where different insurers can bring the data together about the claims that they receive from their customers who submit claims, for example, for car accidents. And then basically this data clean room helps the different insurers query the data in a way that they can understand, for example, if a specific claim, depending on specific indicators that the customer is submitting, is suspicious or not. And the plan for us today with my colleague Andung is basically to show you how we've used Edgeless Systems tools, in particular EGo and EdgelessDB, to build and to enable this data cooperative, which is basically a data clean room where insurance A, insurance B, and insurance C put together their data sets about claims, and then each of them can individually query on some specific indicators, for example, the social security number, the phone number, basically to understand how many times those indicators have been seen, not only on their individual data set, but in the full ecosystem. And then we have a very simple logic that is basically counting the number of times that those data appears across the different data sets, compares that with a threshold, and flags the submission as a suspicious or not. And depending on that, as part of their business process and their workflows, each of the insurers can take the appropriate decision, which could be about enabling that claim to be submitted, or to basically put that on hold in order to run some more checks before accepting that specific claim, or at least understand what's going on in the ecosystem, of course, without having to know individually who are the other insurers that have seen their customers, in which specific context, and under which circumstances. I'm going to hand over to my colleague Andung in a second. As I said, this runs on Edgeless Systems technology. It runs on Azure, leveraging Intel SGX type of secure enclave. Over to you, Andung, for the architecture discussion as well as a live demo.
Okay, thank you, Giuseppe, for the introductions. I'm going to share my screen. Okay, so as we already mentioned, this we developed this POC use case to get acquainted and also like to get the hands-on experience with Edgeless system tools and capabilities. And particularly for this POC, we use two tools. The first one is EdgelessDB. So EdgelessDB, it is the full SQL databases that can run inside the secure enclave. And yep, thanks to this capability, we can use EDB to store sensitive data from insurance companies, and each insurance companies can work on their sensitive information about clients securely directly with this Edgeless. And the second tool we use is the EGo. So basically, EGo is a framework to build confidential application in Go. And then we use EGo to provide or to create a trusted app. So this trusted app is having the logic for the fraud detection, for the fraud indicator. So yeah, for this for the scope of this POC, we make it very simple, just to count the number of submitted claims or the number of accidents already happened by a specific client. And yep, to go a bit into detail of the concept of data clean rooms, we only use for insurance fraud detection. We have here, as you can see on the left one, is the trusted environment with data clean room using EdgelessDB for the three small blobs here. So that is the sensitive data for a different insurance company respectively. And thanks to EdgelessDB manifest .json, the file, it can declare which user of the database can access to which particular databases and with which permission. And then since then we also provide the EGo trusted app with the logic in order to provide the proper result for the fraud indicators. And here is the ideal architecture that we would have for each insurance company in order to have their proper data clean rooms. So for the scope of the demo, again, we build pretty simple one in the one single VM. That's why we have this simple backend API that is shared between different insurance company, Go client. But in reality, that will be split, and each of insurance company will have their own backend API and their own full stack separately, and connecting to the EGo app and the EdgelessDB. So without further ado, I will go to the demo one. So as you can see here, we have two columns. The left panel is the way that we interact with the demo, and the right one is to illustrate what's happening behind the scenes. So the first thing we have to do, for example, for the insurance company A, is to verify the connection or the trustability. So as you can see here, he has to verify two things: the trustability to the trusted app to get the indicator, to get the fraud detection logic. And the second thing is to verify the trustability to the EdgelessDB. And as you can see on the screen here, they are untrusted, so he can proceed to the next information for different client retrieval. So in here, insurance company A can get information from all of his existing client. For example, in this scenario, there's the particular client submitting the incidents. So firstly, the insurance company A need to run this logic to see if it is the valid request or not. And in here, as you can see, the result is current accidents. What does it mean? It means that these are the information that's having inside the insurance company A database. And the total past accident count is the total occurrence, the total record that happened in the whole data clean room without knowing in particular who's having how many. So, and very simple logic in here. It's just having the threshold to know if it is the valid claim or not. So in this scenario, we have like a total of 4 accident count. So it's a valid one. So the insurance company will submit a new one. So as you can see, that will begin. It will change, updated by 1, so that the local information from the insurance company A becomes 2 for this particular client. So the next thing, for example, if this specific client also trying to request for the new new incident, new claim on the insurance company B, so the insurance company B will run again this checking with the client SSN. And as you can see here, for example, in our case, it's simply just if the threshold is more than 5, it will flag a suspicious claim for this particular request. So the insurance company B need to manually check for this request before going further. So that is for validating and checking for the claim fraud detection. And the last scenario I would like to show, for example, is by some incident that the manifest JSON of one particular company, for example, in this case, the insurance company C doesn't match, so he cannot proceed further with this scenario because he doesn't have the matching signature with EdgelessDB. So this is just the simple way to show that we always have the trusted and verifiability between the insurance companies with the EdgelessDB and the verifiable apps. So yeah, that concludes my demo.
Thank you, Andung. Awesome presentation. Thank you so much. I love what you've built there based on our technology. I think it's a very, very good showcase. Thanks. And now to the last part of this webinar. So this is the slide I showed earlier. So so far, our friends from Accenture, they have been presenting about how to enable multi-party data sharing. And now I'm going to talk about preventing data breaches using confidential computing. And yeah, this is the focus of what we do at Edgeless Systems. And here's our open source products portfolio. On the right-hand side, you can see the tools that Andung and Giuseppe used to create this amazing application that they just demoed. And yeah, these are tools focused on developers, and they enable developers to create such tools on the Intel SGX platform. And on the left-hand side, we have our enterprise product, which is called Constellation. And Constellation is 100% focused on increasing the data security of Kubernetes-based workloads on-prem and on the cloud using confidential computing. And the idea of Constellation is to wrap an entire Kubernetes cluster into a confidential computing envelope. So it's like we are extending the concept of a single secure enclave to your entire Kubernetes cluster. And you can set up Constellation just like any other Kubernetes distribution. And in fact, Constellation is a CNCF certified Kubernetes distribution. And once you have set it up, you can just use it as any other Kubernetes, and you can use it to scale your workloads up and down. But Constellation ensures that all data is always encrypted at runtime, on the wire, and also when it's written to cloud storage, and ensures that everything is shielded as one big piece from the infrastructure. And Constellation makes this verifiable for the DevOps engineer. So the DevOps engineer, once they set up Constellation, they know that it is a good cluster, they know that it's running on confidential computing hardware, and they know that it's running good software. And this works on Azure, Google, and to some extent also on AWS. We are working on that. And it's free open source and also has an enterprise license offering. And all that is required to set Constellation up are essentially two commands. It's very easy. Constellation creates a cluster, Constellation init initialize the cluster, does all of the verification magic, generates keys, distributes keys, and so forth. That's all happening behind the scenes. And once that is done, you can just use it, as I said, as any other cluster, and you can connect you as a DevOps engineer, or you can tell your DevOps engineer nearing department to connect kubectl or any other Kubernetes frontend to it. And here I'd like to show you a quick demo. And please bear with me while I switch windows here. There we are. So here's a quick recording of us setting up Constellation on the Google Cloud. And this is a bit, it's replaying a bit faster than normal, but essentially, yeah, it's setting up a cluster with 3 control plane nodes, 5 worker nodes on Google. It's initializing the cluster, generating all the keys, and then it's done. And then Kubernetes is automatically configured to connect securely to the cluster and then one can install arbitrary containerized applications on it and scale them up and down. And here in the other tabs in this window, I have light applications that are running on Constellation. So rocket.edgeless systems, this points to a Rocket chat server, something similar to Slack, that's running end-to-end confidential on Kubernetes. Everything that's happening in this chat here is end-to-end encrypted, even during processing. Please feel free to join our little party here. And the other demo we have here is GitLab. So I'm sure you are familiar with GitHub. And GitLab is an open source variant of Git, or alternative to GitHub. And here we're running GitLab, an entire GitLab deployment on Constellation. And this deployment includes a PostgreSQL database, a Redis key value store, a load balancer, a web gateway, and many other services. And they're all running end-to-end confidential and scalable on Constellation. And this simply wasn't possible before. This wasn't possible before confidential VMs were available, and also not before Constellation became available. And if you want to check out Constellation, all the source code and binaries can be found on GitHub. There's also some extensive documentation and also benchmarks. So oftentimes we get the question, how fast is this? And the answer is, it's pretty fast. I don't want to go into detail, but typically we say overhead is between 0 and 10%, depends on your workload. And especially latency is typically very good. And here we have some public benchmarks where we use the popular KBench benchmark to compare Constellation to the native GKE and AKS Kubernetes on Azure and Google. So so please feel free to check that out. And we are quite pleased with the performance. And switching windows again. 1 second. So to summarize, Constellation is the first confidential Kubernetes, makes it super easy to use confidential computing at a large enterprise scale. And the key features are everything in the cluster, including the control plane, is always encrypted. Everything is verifiable. We have some great techniques for end-to-end verification of the entire cluster. Great stuff. And performance is good, and easy, and integration is super easy. So if you already run Kubernetes somewhere, you can also use Constellation. So sometimes we get the question, why do I need a confidential Kubernetes? Why can't I just spin up a confidential VM and maybe run a container in there? And the answer is, if you don't protect everything end to end, if you just protect single containers, single apps, single workloads, then you're leaving a lot of gaps. So you may run, for example, node A in a confidential VM or node B, and that's great. But if other components don't verify these components, then not much is gained. And if you don't encrypt everything that's happening, then attackers can still siphon off data from the unprotected parts. And they can maybe just take control of your control plane and run arbitrary commands inside your confidential VMs, and then you haven't gained much. And with Constellation, the approach is wrap everything inside this green box, encrypt it, shield it, and make it verifiable. And I think that's the best approach, and that's why Constellation exists. Okay, so use cases again. So we had use cases for confidential computing, now use cases for a confidential Kubernetes. And of course, first and foremost, the use case is prevent data breaches. So Constellation protects against a range of infrastructure-based threats, like malicious insiders, cloud admins, malicious co-tenants, things like that. And sub-use cases of that are that if you have this top data breach prevention, then you can move more workloads to the cloud. And this is a big use case that we're seeing currently, and where we're working with a range of customers in different sectors, for example, in the financial sector. The other big use case is this now allows you to meet regulatory requirements. So you can, for example, now that you know that all data is always encrypted, you may be able to move sensitive workloads from on-prem to the cloud, or maybe move it from a certain locality like the EU to the US while staying compliant. And that's a very strong use case. And we're also seeing first signs of regulation that specifically asks for confidential computing. So in different European countries, confidential computing is now required for certain e-health applications. And yeah, we believe that many other sectors will follow suit. And finally, a super interesting use case is sub-use case is making SaaS offerings more trustworthy. So we see across verticals that certain companies cannot use certain SaaS offerings because, well, you're giving your data to someone else and it's running on someone else's computer. But with confidential computing and Constellation, if you're running your SaaS in a confidential cluster, this can be different. And these are super exciting use cases, and we're just getting started to exploring these with customers. All right, so that was my final segment on data breach prevention and our open source products. If you want to learn more about these topics or about confidential computing in general, then here are two great resources. Left-hand side, we have our confidential computing white paper, which we put a lot of effort into. And you can download that for free on Edgeless Systems. And it will cover all the aspects I covered today and more. And on the right-hand side, we have our Open Confidential Computing Conference, which is taking place in March next year. And it would be great to see some of you there. And maybe you even have a good use case and want to present. In that case, the call for papers is still open till December 15. Thank you for your attention. Thank you, Giuseppe. Thank you, Andung. Great work. And if there are any questions, please type them in the Q&A chat window and we'll try to answer them. Thank you. Let's see. Okay, there's a question around if there will be a recording. I think there will be a recording. Yeah, that was easy to answer. Any more questions? Let's give it like 10 more seconds. Apparently I'm looking at the wrong window. There are apparently questions. 1 second. So almost there. Yeah, sorry, this hop-in can be confusing at times. There it is. Okay, first question. Maybe that's a good one for also the Accenture colleagues. Tell us more use cases. Use cases. It's all about use cases. So we most things we do are under NDA, so it's a bit difficult. But the key use cases we see are data protection, healthcare, IP protection in different industries, and moving from on-prem to the public cloud, or increasing security of public cloud workloads. And there's, Giuseppe.
Thank you, Felix. And you mentioned one where we've put quite some effort and also run some deep experiments, and it's one in healthcare, and it's about using federated learning for illness detection. So basically, we've built a framework and a solution where you use the standard federated learning across a network of hospitals. For instance, each of the hospitals wants to protect their individual data sets about their patient data, and they use federated learning. But as you probably know, the way the model gets aggregated in the standard federated learning is not always very secure, especially against malicious servers, malicious aggregators. And that's where we've combined, for example, federated learning with confidential computing to make sure that at least the secure aggregation runs in a secure enclave, so that we basically protect the contributions from each of the hospitals that are training the model in order to release a new model that they can all use. And potentially it's more powerful because it's been trained on a much wider data set. And then, as Felix mentioned, in financial services, the insurance one is pretty standard. We've seen it around for quite a while. But then we've also been working on some public cases around anti-money laundering in the financial services sector. So imagine a group of banks who decide to use confidential computing, for example, to train a model to build a much more powerful model for AML, for example, using graph technology. Those are all things that we've been experimenting in the last year or two.
Yeah, great cases. In connection to this, I think there's another question regarding use cases in telco. Yeah, there are some very exciting use cases in the telco space. What we see is that 5G network functions is something that many operators are looking at. I think there's an industry-wide move to get these workloads to the cloud, containerize them, and protecting these workloads is important because of regulation. Of course, it is important, privacy-relevant data. Okay, next question. What is European compliance which requires confidential computing? So in Germany, there are two big applications in the healthcare sector. They're called e-patient data or e-Patientenakte and e-prescription service or e-Rezept. And the requirements around these services, they're nationwide services that are supplied to all 70 million insured Germans. And the requirements around these services coming from the government are such that they can mostly only be met with confidential computing. And most or all players in the space are already using confidential computing. So it's one of the first sectors and countries where confidential computing is a requirement. And there, I believe in Norway, there's similar regulation. Next question. How can you guarantee the security of Constellation? So that's a tricky one, right? We can't possibly formally verify every single line of code because we're running entire Kubernetes inside there. But we invested heavily into supply chain security. So all of Constellation is open source. Its builds are reproducible, and we use the latest supply chain security platform, SigStore, to publish every single release and to publish the corresponding signatures and to make it globally visible which are the good Constellation packages. And when a Constellation cluster is set up, every single node is verified with respect to this public global information. And it ties back to the CLI. So the CLI that sets up the cluster verifies the first node based on this global public information. And then this node verifies all the other nodes. And then in the end, transitively, the DevOps engineer knows that it's a good cluster that is running the good image. And that's great. And I think that's quite an achievement. However, we cannot guarantee that possibly every single line of code that's running in there is free of bugs. On which cloud platforms does Constellation run? Do they all have the right chips? Google and Azure have the right chips. AWS doesn't have the right chips. Constellation still runs on AWS, but it doesn't run with runtime encryption. So, or at least not with full runtime encryption. AWS, you don't get full runtime encryption. You can get attestation based on TPMs, and that's what we use. So you get attestation and end-to-end network and disk storage encryption and all of the other goodness, but you don't get full runtime encryption. And once AWS enables the features in the cloud, we will also support that. Then there is, one second. Why do you think this technology can help with compliance? Data has to be decrypted at some point. Will compliance officers accept that? I think it really depends on the regulation. And to some extent, regulation has to catch up. There are some interesting discussions going on in different parts of this world, whether confidential computing style encryption is equivalent to traditional encryption, that is encryption at rest. And I believe that we will see some regulation picking that up. And once we have that, you can, you can use confidential computing and stay compliant while actually processing the data. But it will take time, or may take time. Next question. Are there any security certifications? Are there any certifications which may apply or which are even granted to Edgeless? Short answer is that's work in progress. Next question, in which geography countries do you see fast adoption of confidential computing? I think that's a very subjective view. We see we have some telemetry, and we also get interesting inbounds from different parts of the world. It seems like Europe is leading to some extent because of its tradition with regard to privacy and data security concerns and regulation. However, the US is also typically, or unsurprisingly, very strong. And I think there is maybe a 60 to 40, 70 to 30 split between the US and Europe. If we, for example, look at the attendee numbers of our conference, then I think 60 to 70% of the attendees are from the United States, which doesn't mean that the market is split like that, but I think a good part of the tech is being built in the US, and maybe more users are in Europe. That could be a good description here. Next question is, failures in CPU design, especially at Intel, are nothing new. I would never rely on such a single parameter. What do you offer as an add-on? So CPUs can have bugs, and there are side channel vulnerabilities. We don't see this as a black and white thing. It's not totally binary, right? You can probably break an Intel SGX enclave or a confidential VM with enough time and dedication. And there may even be weaponized exploits out there that you can just fire at an enclave with one click, but that's rare. And you still, normally you still get additional security. Like I said, it's not black and white. You're increasing the bar. Maybe you're increasing the bar by quite a bit. And around that, as I said, we have a range of pretty cool features that keep the data encrypted on cloud storage, on the wire, and make the integrity and the software of your nodes verifiable. But yeah, nothing is unbreakable. I think that may be it. Give me a second to double check. Yeah, that's it. Okay, so it's a wrap. Thank you all for attending. Thank you for the great questions. Giuseppe and Dung, special thanks to you guys. Thank you so much, and yeah, we should do this more often.
Thanks everyone for joining.
Thank you.
Thank you. Bye.
Bye.
Goodbye.